here, which is my problem. My point is that I look better distinguishabilities than distances. And why? Because distances are related to particular cases. No, I agree with you that maybe you can have a sequence of parameters of each fuzzy set. Maybe. But if I don't know the meaning of these parameters, it will be difficult. This is the best I was able to produce after thinking on the subject for several times. 3 or 4 years. Of course, you can improve. I presented with this aim to suggest you the problem, to think more.
The last question. What do you mean when you say the degree of resemblance is 1? It is not equality. You are saying that they have a degree 1 of
Yes.
What means that?
That the degree is 1. that is the look, this is 0.9. There is no one single case. No, look, if the degree is 1, is that the sum of Ovchinnikov plus I is 2, and this means that both Ovchinnikov and Y are 1. Then the maximum degree of resemblance.
It's needed to define what we are looking for.
This could come from, I was telling to Sergio, that to find a DR, verify some properties in relation with F. I accept that this would be a good one.
I think I can read that this degree verify antisymmetric property. This degree verify antisymmetric property, what means if the degree is 1, you have to be the same fuzzy set. In the way you define it, it looks like if the degree is 1, you have to be the same fuzzy set.
If the degree is 1, both Ovchinnikov, the addition is 2, and hence both are 1. I'm not sure that if Ovchinnikov is 1, or let me say, if this is 1, this is 0, this is 0. Well, I'm not sure if the character of Riemann integral gives that the function, that this function here should be identical with 0. I think not. I think that they can differ in a numerable set of values.
You could, if you use the absolute value inside the integral, then it's true. Otherwise, no. If the functions are something continuous, upward and continuous, something like that.
I don't remember now for a lot of years when I have not
What is
lecturing on theorems. But as far as I remember, it could be possible that Riemann integral is 0 without the function being identical.
No, almost everywhere is 0.
Almost everywhere.
Yeah, but if continuous, then it's 0 everywhere.
Yeah. This is, in any case, are pathological cases.
Yeah.
Pathological cases. Okay. Anything else?
I have a doubt. We say that the relation FR is not transitive, but when we are talking about the degree of the relation, we deal with indistinguishabilities that are transitive. So why we don't collect
T-transitivity does not imply transitivity. Worse. If you take, for example, the only Chris relation that you can obtain in a good way with the DR, that is to say, F mu is equivalent with sigma even only if the degree is positive, this relation is not transitive. Then it's true. FR is not transitive and DR is W transitive. Why? Maybe because I introduced the idea of T-distinguishability and I liked T-transitivity. But T-transitivity is not the same as transitivity. It is the famous Menger example in which a blind person to think on the geometry of sensations in the hand. I can here, and I perfectly distinguish from here, but they have very close to this point and very close to this point, and I cannot distinguish. This relation of distinguishability is not transitive, but there are models in which this is transitive. Then I don't see a clear link between classical transitivity and T-transitivity. Because of that, it was not working. And that is for me nice situation in which the degree is a fuzzy equivalence. It's a fuzzy equivalence. It would be interesting, for example, to take this degree or another degree and to study the classes of fuzzy indistinguishability and to relate these classes with the families. I would say, I have families of ressemblance defined through the relation Fr. I introduce the degree. This is a indistinguishability. I can consider the classes. Now, these classes are fuzzy sets. That is, the fuzzy set, the class of the object mu, is those fuzzy sets that if the degree, this is a fuzzy set. The relation between the crisp and the fuzzy places is interesting to be studied. Anyway, my last conclusion was that this is not enough. That it maybe could be enough to say that two uses of the same predicate, they have family resonance. And maybe you can choose one degree because the degree, sorry, you can choose one use because the degree is big, or to refuse this use because the degree is low. Okay, but to enter in the language, as Rudy said and Sergio said, this is not enough. I don't know if the problem is with prototypes. I don't know. But what the problem is that you need processes, not only fuzzy sets, but processes, dynamical processes. Because how we decide, for example, that the word anyway, a word will have families resemblance. The first word was used in a family environment. The second word was used in business. And suddenly we decide to use the second word for family purposes. And from this moment, this new word has family resemblance with an old word that we were only using in family purposes. This is the history of language. The movement of words that are used in this environment to another environment, and then they acquire a new meaning. And they show family resemblance with all words that were there. And it's because of that I think that we need a new idea. I don't know this new idea. But it's an idea similar to that occurred in probability theory, when people start talking on in probability, how to say, statistical variables to move to processes, Markov processes, Lyapunov processes. I think that this is the point we have made.